Okay. Today we will discuss about the shear force diagram and bending moment diagram of an overhanging beam with UDL. So write down a problem. Draw the shear force and bending moment diagram of an overhanging beam with UDL as shown in figure. Draw the SFD and BMD of an overhanging beam with UDL 4.5 kilonewton per meter over the whole span as shown in figure. The problem is draw the shear force diagram and bending moment diagram of an overhanging beam with UDL 4.5 kilonewton per meter over the whole span as shown in figure. So, to solve this problem, first we have to draw the beam with UDL. So, this is your overhanging beam. 4.5 kilometer per the diagram. There is an overhanging beam A, B, C. A, B, C. Having its length AB is equal to 3 meter and BC is equal to 1 meter. This beam is subjected to UDL or uniformly distributed load 4.5 kilonewton per meter over the whole span. We have to calculate the bending moment and shear force of the beam, as well as we also have to draw the shear force diagram and bending moment diagram. So now solution. The first step is your we have to draw the free body diagram of the beam. So let's first draw the free body diagram of the beam. You just while drawing the free body diagram, you just remove this beam support and apply two support reaction, one horizontal support reaction and one vertical support reaction. And if you remove this roller support and put a vertical reaction. Okay, let's draw. One meter. So this is the free body diagram of the main beam. Okay. Now the first step is calculation of support reactions. So apply the condition of equilibrium. Calculate the value of HA, BA and BB. So in equilibrium, summation of horizontal force 0, that means summation is 0, that means HA is equal to 0, only because only one horizontal force is there in horizontal reaction. So now again in equilibrium, summation of vertical force is equal to 0. How many vertical forces are there? There are 3 vertical forces. Here EB to support reactions and another UDL which is acting vertically downwards and E and BB acting vertically upwards. So equation of E becomes EA plus EB minus total UDL means 4.5 into 3 plus 1 meter. That means total UDL value is equal to 4.5 into 4. Clear? Total value 4.5 kilonewton per meter. Total UDL length is 4 meter. So total load becomes 4.5 into P1 3 plus 1. So it becomes 4.5 into 4. There is no other vertical force. So this equation becomes EA plus EB is equal to how much? 18. Equation number 1. The next condition of equilibrium is moment. Now let us take moment about a point. Okay. Now taking moment about a the summation of n at a and clockwise 0. So if I take moment, the equation becomes due to with respect to a point, the moments comes due to 2 vertical loads. One is for EB, one is for the whole UDL. Because for BA there is no moment, or HA there is no moment about A. Only moment will come due to EB force as well as due to UDL. Okay. So now moment about A for BB is your BB into 3 meter, BB into 3 meter. This makes anti-clockwise rotation. That means in respect to anti-clockwise, and anti-clockwise is your positive, and this UDL makes clockwise rotation. So okay, minus. Total UDL is 4.5 into 4. 4.5 into 4, and this UDL acting through its CG, that means how much distance? 3 plus 1 by 2. Through its CG means 3 plus 1 total length, and it's half 3 plus 1 by 2, so it becomes 4 by 2 equal to 0. Now from this equation you can calculate your B is equal to how much? 12. 12, is correct? AB is equal to 12. 18 into 36, 12. 12 kilometer. Is checking 12 or not? 12. Now put this value in equation 1. Calculate. Now put BB is equal to 12 kN in equation 1. Then BA plus 12 is equal to 18. Then BA becomes 6 kilonewton. And BB becomes 12 and BA becomes 6. Clear up to this? Okay. So we have found BB is equal to your 12 kN and BA समान 6 kN. 6 kN, right? Okay. The next step, what is the next step? Either calculation of shear force or bending moment. So now next step, Calculation of shear force. Let me this start. Now calculation of shear force. First, draw the sign convention. Here I am drawing the sign convention of glass. What sign convention of shear force? Right up. Glass is right. Right up. Right down, left up. In suppose. Right down, left up, glass. And minus flexion. Minus down, minus one. Now calculate shear force. Shear force of A shape at C. C. If you stand at C, sorry, right down, left up. Sorry. Sign convention. Right down, left up. Last sign convention, right down, left up. Right down, left up. Now, shear force at C. If you stand at C, look towards right. There is no force, so shear force at C is equal to 0. Now, shear force at D. Shear force at just there is a support at the median. So we have to calculate the shear force at right of B and left of B. Here, shear force at just right at right of B or SF B plus. How much? Shear force at just right of B. How much? Yeah, shear force at just right of B. You just see only this portion. 4.5 into 1. 4.5 into 1. Only this amount of shear force will come. 4.5 into 1 meter plus 4.5 Newton per meter. So 4.5 into 1. Plus or minus, write down. This one, plus. So 4.5 Newton. Now shear force at A. Shear force at A is shear force at A is nothing but your VA. Only VA 6 kN plus VA. Right down, left up. So this one plus VA or 6 kN. Now shear force at just left of B. Left of B. Consider only this is BA part. Just left of B. What exactly happened? Shear force at right of left of B or A shape B minus how much? Anyone? VA minus you stand here, looks towards this direction. Only VA and this UDL will be there. So VA minus 4.5 into 3. VA minus 4.5 into So it becomes 6 minus 13.5 from now. 13.5, তাই তো? 4 থেকে 12, 13, 13 ঠিকই আছে। So it becomes how much? 7.5 minus 7.5 minus 7.5 kilonewton. Okay, minus 7.5. So SF B minus 1 minus 7.5 and A6 plus 4.5. Now draw the shear force diagram. Now shear force at C how much? 0 at B plus 4.5. So just do it at right side. So it becomes plus 4.5. Because this one is your 4.5. Just right side. At left, shear force of B minus 7.5. That means how much? Minus 7.5. Minus 7.5. Now shear force at just left of B is your plus 4.5 and shear force at just right of B is your plus 4.5 and shear force at just left of B is your minus 7.5. Now the shear force at A how much? Only BA plus 6. So let's draw 6. It's much 6. Okay. Now how to draw shear force? First, we have to join BC from C to the right of B, then from left of B to A or A to left of B. How to join C to the right of B? How to join with the help of parabolical or straight line? This is shear force diagram. Straight line. I am discussing about the shear force diagram. So we will join C and triangular and straight line. To join with straight line, it becomes triangle. Just join C and B. This is your SFD. Okay. I think there will be no confusion. Join B plus and A by a straight line. Now from here these two will be joined like this. Now we will join B minus to A or A to B minus A to B minus. That means this point A B C. Here this point and this point. How to join? Simply with the help of a straight line. Again there will be triangle. So now join. This is nothing but your shear force diagram. Right. So if you see, there is a point. Suppose N or D. There is a point D. A, B, C. There is a point. There is a point D where bending moment changes from minus to plus or plus to minus and then shear force. there is a point D where bending moment changes from plus to minus or minus to plus. Shear. There is a point D where shear force changes from minus to plus to minus. The total value is your 0. Now you have to keep in mind that where shear force changes sign or shear force becomes 0, at that point bending moment will be maximum. Right now, right now, where shear force changes sign, at that point bending moment is maximum. Okay. When shear force changes sign, যেখানে shear force sign change করে বা 0 হয় সেখানে bending moment টা maximum হয়। Now, next step is your calculation of bending moment. Calculation of bending moment. Next step is your up to this anyone have any questions? Now calculation of bending moment. Calculation of
Hello. Sir, একটুখানি ফোনে ছিল। হ্যালো।
calculation of first sign convention, sagging positive and walking negative. So sagging becomes like this, sagging and sagging. That means towards the right side of the section anti-clockwise positive, towards the left side of the section clockwise positive. Okay. And minus is your now bending moment at C. Calculate bending moment at C. BM at C. How much? 0. Bending moment at C. 0. No force. So no moment. Bending moment at D. Bending moment at D becomes only, that is, while you are calculating bending moment at D, you just stand here, looks towards C, you will see only this amount of UDL force. So, bending moment will be how much? 4.5 into 1 is the load, and distance is distance 1 by 2.
0.5
Because UDL acts through its CG. So 1 by 2 minus, because this creates side hogging. Clockwise. Clockwise means minus. So minus, that's all. So how much? Minus 2.5. You have to turn it up. Now ending moment at A. At A, how much? Anyone bending moment at A? Bending moment at A? At A point. Yeah. Bending moment at A. Bending moment, not shear force. Bending moment. Always 0. Because it is a hinge support. Hinge support, bending moment is 0. 6 can 6 into 0 2. Okay. Now, draw the bending moment diagram. Very simple. Now draw BMD moment at C 0. Moment x is equal to your 0. Moment at b minus 2.25. So let us say this amount here minus 2.25. Okay. 2.25 and at a. Now how will you join a and b? A, C, D. Okay. How to join BC? Parabolic curve becomes like this. Now how to join B and A? Parabolic curve. Because UDL, I am discussing about the bending moment. Bending moment always parabolic when the loading is UDL. So how to join? This may be like this, maybe like this. Okay. Which one will be better? This will be like this. Which one will be the right? 1, 2 or 3? 3. I will say 3. I will explain. I told you where shear force 0, bending moment maximum. You see these two diagrams. Suppose this diagram or this diagram or this diagram. 1, 2, 3. Which one will be correct? For 1, this amount of bending moment. For 2, this amount of bending moment. For 3, this amount of. So 3 will be correct. Okay. I will calculate what is the maximum. So bending moment diagram becomes like this. Okay. So BMD diagram as this is the how much amount of bending moment I need. How much? First, I have to calculate the what is the position of B. That means where maximum bending moment comes. Let us say maximum bending moment comes at point B or at a distance x from A support. I am saying the distance between A and B is your x. The distance between A and B is your x. So this distance is also how much? X. This is also x. Same point. Point is same. This is also x. Similarly, this is also x. As shear force at B changes its sign and shear force at B is 0. So bending moment is maximum at B. Okay. Let us say BM max maximum BM at a distance x from A support. Okay? আমি মনে করছি যে যেখানে ম্যাক্সিমাম শেয়ার ফোর্সটা 0 হচ্ছে বা সাইন চেঞ্জ করছে সেই পয়েন্টটা A সাপোর্ট থেকে দূরত্ব x থিটা। ঠিক আছে? এবার x এর মানটা আমাকে বের করতে হবে। জানি না তো x এর মানটা বের করব আমি। তাহলে পেয়ে যাব x মানটা পেয়ে গেলে এখানে দাঁড়াবো, এখানে আমি দেখব কি মোমেন্ট আসছে তার জন্য। এখানে রিয়েলটা আছে আর বিটা আছে। x এর মানটা বের করলে এই পার্টে বন্ধ করতে হবে এই করে বের করব। আমরা ক্লাস 9 এ পড়েছিলাম সদিশ কোণী ত্রিভুজ বা সদৃশ ত্রিভুজ, তাই না? এরকম করে চলে যাচ্ছে এই একটা তাহলে কি এই বাহুটা বা এই কোণ এই বাহুটা এই বাহুটা সমান, বাহুগুলোর অনুপাত সমান হয় ত্রিভুজের, তাই তো? এই কনসেপ্টটা কাজে লাগাবো। এখানে ত্রিভুজ দেখো তো, ত্রিভুজ এ এই ত্রিভুজটা দিস ত্রিভুজ and this ত্রিভুজ আর সদিশ তাই না? সদিশ ত্রিভুজ। তাহলে from similarity of triangle, from diagram of SFD between A D B ADB এর মধ্যে ত্রিভুজ আছে সদিশ টাইপের, তার উপরে বাহুগুলোর অনুপাতগুলো সমান হয়। from diagram of SFD between ADB AD যদি x হয় তাহলে BD সমান কত হবে বলো তো?
x
পুরোটা তো 3টা, তাহলে 3 x। এবার ত্রিভুজের করো এই বাহুটা বাই এই বাহুটা, এই বাহুটা বাই এই বাহুটা, তাহলে কি দেখতে পারি 6 বাই 7.5 সমান x বাই 3 x। ত্রিভুজের এই বাহুটা বাই এই বাহুটা divided by this বাহু divided by this বাহু। So we can write from this two triangle portion between ADB 6 by 7.5 is equal to x by x 3 x। So write down x by 3 x 3 x समान 6 by 7.5। very simple। now calculate x from here, remove this, calculate, solve this, it becomes how much? Calculate please। So that's 1.33 meter. You can check. You can check this one. 1.3. You come 1.3. 1.3. That means maximum bending moment at a distance 1.33 meter from a support. Now calculate the value of maximum. Now calculate the value of maximum bending moment. Calculate. M max or maximum EM criteria is equal to 1.33 meter। কত হবে? এখানে দাঁড়িয়ে যাও, দাঁড়িয়ে কোন দিকে দেখবে? ডান দিকে না বাঁ দিকে? না অবশ্যই কোন এদিকটা দেখবো, বাঁ দিকে দেখবো। এই যে দাঁড়িয়ে এই দিকে দেখবো, কি হবে? ম্যাক্সিমাম পিএম at the point maximum BMD the point how much? DA into x, DA into x minus 4.5 into x into x by 2, because this is your x, this is your x. Okay, you stand here, it looks towards A, so DA into x meter and is moment into DA and W, and there will be moment into UDL. So 4.5 UDL into distance 4.5 x and its CG x by 2. So it becomes x into x by 2. Now calculate this value of DS 6 x equal to 1.33 minus 4.5 into 1.33 square by how much? Please calculate. 6 into 1.50 minus 4.5 into 1.50 square by 2. How much? 4. 4 kilometer. This value is your 4 kilometer. This is the movement diagram. Does anyone have any questions?